Good morning, guys. We're going to look at day 11 and day 12. There will be no day 11 homework, just day 12 homework, okay? All right, so from yesterday, we looked at how to convert between log and exponential. So I would like you to take a minute and do this top part. You can hit pause and then come back on and check your answers. Hopefully you hit pause. Here are our answers. So remember, we spiral around. So you have 4 to the negative 3 equals 1 over 64, and that is number 2. And then you have 2 to the 6 equals 64. So 2 to the 6 equals 64, and that is B. And then we swoop around. We have 64 to the 1/3 equals 4. And that one is 3. And we swoop this one around, 4 to the 3rd equals 64. And that one is up here in number 1. And then remember on E, when there's no base, it's really a 10. So then you swoop around, you get 10 squared equals 100. And then that one is number 4. So this one down here, write natural log of 1 equals x. So if we write that in exponential form, we need to remember that natural log is log base e of 1 equals x. So when I swoop that around, I get e to the x equals 1. And what does x have to be? X has to be 0 for that to be true. And here, write this one as a log. I have log base 3 of 81 equals x. So 3 times 3 times 3 times 3, how do I get to 81? That would be a 4. Okay. All right, evaluating. Evaluating is now kind of solving what we're doing. The easiest way I find to evaluate is to set these equal to a variable. If x is already in the problem, set it equal to something else. So since these don't have x on them, I'm just going to make these x. You'll see on the backside what I mean when there's already a variable there. Okay. So now I can turn this into an exponential. So I get 7 to the x equals 49. So then that tells me that x would have to be 2 in order to get that answer. Okay, same thing here. We're going to set this equal to x, swoop around, so I get 2 to the x equals 16. So then you have to think for a minute back to that unit when we were doing these, and you get 4. This next one, set this one equal to x. I have 7 to the x equals 1 over 7. So exponential again, to move that to the bottom, that would have to be a negative 1. Okay, so pause for a second, and you guys try this next part. Hopefully you paused and you did some of these on your own. And here's how these would look. So I'm going to set this equal to x. So I get 3 to the x equals 1/9. So then I get x to the negative 2 because I need to square it, but I also need to drop it to the bottom. And then I have log base 4 of 16 equals x. So 4 to the x equals 16. So I would need x squared in order for that to be true. And now I have common log, that's how we say that. Common log of 100 equals x. That really means there's a 10 down here. When we leave off the base, it's always a 10. So 10 to the what is 100? I would have x squared again. And this last one, I have 3 to the x equals 27. So I have x equals 3. Another way to think of this would be change this so we have the same base. So 27 is really 3 to the 3, same bases. Remember, we can cancel those out, and we would get x equals 3 again. So that's another way of thinking or solving it if you can't remember just straight out 3 to the what is 27. Okay? All right, so that's a little bit of simplifying. Now we're going to look at inverses. Okay? Inverses are when we switch the x and y's and then we resolve and try to figure out what the equation would look like equal to y. We're going to start this with a graph we already know. Our f of x equals 2 to the x, okay? And then we'll graph its inverse. So we can find the inverse by exchanging the x and y values. Therefore, y equals 2 to the x is really x equals 2 to the y. Yuck, I don't want to graph that. That looks terrible with the y up there. So we're going to do this inverse in a minute. We'll deal with that. Let's deal with first our regular graph that we can do. The y equals 2 to the x. So y equals 2 to the x doesn't have a plus or minus, so really I could think of that as a plus 0, or my horizontal asymptote is at 0 because there was nothing added or subtracted. Remember, this needs to be a dotted line all the way across. Once I plug 0 in for the x, I can find my y-intercept. So when I plug 2 in there, I get, or 0, 2 to the 0 plus 0, so that's really 1. So I'm at 0, 1. 2 is greater than 1, so I know that this should be a graph looking like this. It should be a growth graph, okay? I'm only going to check 1 point. When we were doing that unit, I made you check 2 points, but we have a lot more to do here, so hopefully we'll get this in the right direction and that it will be going up on the right-hand side. I'm going to plug 1 in here, so I get 2 to the first, that equals 2, and 2, 1, when I put it on the graph, does go here. It is going up, so I'm going to finish it off. Make sure your graphs hit both edges, and you can see your connected dots. So we have our y-intercept, we have 1 extra point, we have a horizontal, and we have the correct end behavior, okay? All right, what did inverse mean? It meant switching our x and our y values. So without doing any algebra work, if I think about graphing this and switching my x's and my y's, we get this equation, x equals 2 raised to the y, but I want to switch every x and y. So if I go to my horizontal asymptote, if I switch that from an x to a y, I get x equals 0, but x equals 0 is a vertical asymptote. So it changes it to this, and those are completely opposite from horizontal to vertical. Then I'm going to change my y-intercept. Well, that's going to become my x-intercept. Oops, I didn't mean to put a parenthesis on there. So I have my x-intercept now, but an x-intercept is something comma 0. And if I'm switching everything, this really should be a 1 there. Okay, so I'm just switching out all of my x's and y's. So now I would be at 1, 0. If I think about even my little table, everything has to switch for x and y values. So now this ordered pair would become 2, 1. So if I go to 2, 1, I have this. So this one is starting to go like that. You can see that these two are reflected. When we did inverses, we learned that switching your x's and y's really meant reflecting your graph over the line y equals x. And if you see that orange is reflecting down here to this red, this little piece and this little piece are exactly in the same place on opposite sides. So if I keep going with that, this orange one went along here, so this piece is going to have to go down along this. It still follows my asymptote. And then this side over here, I'm kind of like at 210. So if I wanted to make this look really nice, I could go out here to 10, 2 and draw my graph. And my graph again hit both sides. And I can see 2 points in my horizontal asymptote. That's what the inverse graph of our exponential looks like. Okay? So what does that really mean? Exponential and logs are inverses, okay? So if I look at this next piece, it says, in general, the inverse of y equals b to the x is x equals b to the y. But what does this really mean? If I take x equals b to the y, I'm just going to flip this around because when we did exponentials yesterday, we always had the base on the left raised to a power. So if I do this and I turn this into a log like it's asking, I end up with log base b of x equals y. And that's an equation. Y equals like mx plus b if we're graphing a line, but we just happen to be graphing a log. So that's what this equation, this yucky x equals b to the y, would look like as an equation of a graph. Okay, so you're just like yesterday, switching your x's and y's, switching from exponential to log. Now we're going to look at some algebraic properties that do this. Okay. All right, so it says because these are inverses, the following must be true. So we're going to zoom in on here. We want to rewrite log base b of b raised to the x equals x in exponential form. Okay, so that means we want to get rid of this log, and we're going to wrap this around. When I do that, I get b to the x equals b to the x. That looks kind of weird. Why do we have this? Well, if you remember back to our last unit, when we would get stuff like 4 to the third equals 4 to the x, when we would get same bases, if we could get that to happen, we could actually cancel those off, and we could just set the exponents equal to each other to solve. That's what's going to happen here. When I get stuck in a situation where I can't solve it any further with a log, I'm going to turn it into an exponential, and hopefully something like this will happen so I can cancel those b's off. And of course, x equals x. That is a true statement. Okay? So we have this property here that shows us that you can take a log or take the exponential of something that's raised to a power. Okay? We're going to do the same thing over here. We have an exponential raised to a log. We're going to take the log even though there's a log in it. Okay, so I want to rewrite the word log. Then I'm going to swoop this b around, and I'm going to rewrite this. So I have log base b of x equals, hit my equal sign, and then what's it equal to? Log base b of x. So it's showing that these two things are equivalent. Both sides are equivalent. Just like when we had the 4 to the third equals 4 to the x, if you have same bases, you can cancel. Here, I have log base same bases. So if I had something like log base 7 of 3 equals log base 7 of x, since they're the same log base, I can cancel those out, and I can get 3 equals x, and I could solve that. Okay, so these two operations, log and exponential, are inverses. They do and undo each other. Kind of like saying square and square root are opposite. Squared and square root undo each other's operations. Exponential and logs undo each other. Okay, so we're going to practice some of these now that have numbers. So I'm going to set this equal to x just like I did on the front side. There's not already an x in it, so I'm going to evaluate. It's already a base 7, so the only thing I can do is turn it into a log. So I'm going to start here, and I'm going to wrap around. So I have log base 7 of x equals, I'm going to rewrite that on top, log base 7 of 5. Since they're both log base 7, I can cancel those out, and x equals 5, so it's equivalent to 5. Okay, this one is a log. So I'm just going to set it equal to x, and I'm going to write it as an exponential. You're going to go back and forth between them. So I get 6 raised to the x equals 36. Well, that's nice because 6 squared is 36. So x equals 2. If you're kind of like, how did you get that? You can also think of this like last chapter where we had 6 to the x, and we had to turn that 36 into something with a base 6. That would be 6 squared. So then you can see same bases, and I get back to that same answer. Okay? Now, this one already has an x built in, so I can't set it equal to x. I'm going to set this one equal to y. Okay? So now, since it's already log, I need to change it into exponential, so I'm going to wrap this around. I get 3 to the y equals 27 to the x. Remember, I'm trying to solve for the y. I'm trying to solve for whatever I set it equal to. I need to get this y by itself. So I have 3 to the y equals 27 is really 3 to the third raised to an x. A power to a power is multiply. So this becomes 3 to the y equals 3 to the 3x. Same bases. So y equals 3x, and I'm done. Okay. Next one. e raised to the natural log of 2x. That's kind of yucky, but we're going to do it. We're going to set it equal to y since x is already taken up in there. So since this is an exponential, I have to turn it into a log. So I'm going to wrap this around, and I get log base e of y equals natural log of 2x. Those two look different, so let's make them both the same. I'm going to change this log base e into a natural log. So I get natural log of y equals natural log of 2x. Now that those match, I can cancel them out, and y equals 2x. That's what we're looking for. Okay? If you need to go through these again, you can slow it down, and you can rewatch this. You've got it posted. Okay? Log base 10. If you're missing a log or a base, make sure you put 10 in there. It's called the common log. We're just lazy and we don't write it. And I'm going to set that equal to y. So I want to get rid of the log and turn it into an exponential. So I have 10 raised to the y equals 100x. I want these to match. So I want my bases to match so I can cancel them out. So I get 10 squared times x, a power to a power is multiply. So now I have, since 10s are the same, I have y equals 2x. Okay? So pause for a couple minutes and you try this next set. And we're back. Hopefully you paused for a little bit. So I'm going to set this one equal to x since there's no x in it. So I can wrap this around and I get log. Since this was an exponential, I have to turn it into a log. So log base 3 of x equals log base 3 of 81. Log base 3's are the same, so I can get rid of them. And x equals 81. Here, this already has an x in it, so I'm going to set this one equal to y. This starts off a log, so I have to turn it into an exponential. So I want to get rid of the word log, so I have 5. I'm going to wrap this around. I get 5 raised to the y equals 525 raised to the 3x. These aren't same bases, so I can't cancel them yet. I have to change them to same bases. I can't change the 5, but I can change 25 to 5 squared raised to the 3x. So now this gets me 5 to the y equals 5 to the 6x. Now they're the same bases, and I get y equals 6x. Change colors so we can see these. All right, I'm going to do this one over here. So since this one is already equal or already in exponential form, I need to change it to a log. So I'm going to wrap this around, and I have log base 10 of y equals log with no base down there really means log base 10 of 5x. So log of 10 cancels out, and y equals 5x. Okay. Next one, it has a log here, so I'm going to turn it into an exponential. So before I can do that, though, I need to rewrite natural log as log base e, and e to the 3. I'm going to make that equal to x since there isn't one in the problem. So now I can get rid of the log and go e to the x equals e to the 3. The e's cancel out, and x equals 3. And our last one. So since there's already an x in there, I'm going to set it equal to y. It starts with a log, so I want to turn it into an exponential, so I'm going to wrap this around. 2 to the y equals 16 to the x. I need to turn that 16 into a 2 raised to a power, so that's 2 to the 4th times an x. So then I get y equals 4x because the 2's cancel out. Okay? So rewrite those. Make sure that you followed along. Make sure that you write them because you're not going to remember them until you write them. Now we have to find the inverse. Okay? So to find the inverse of something, we have to switch the x and the y's, isolate the y or resolve for y. That's what we would say when we were doing that unit. And then rewrite the function in inverse notation. So our inverse notation is changing it from y to y raised to the -1. Okay? So find the inverse down here. Y equals log base 4 of x. So now I want to go x equals log base 4 of y. I switched my x's and y's. Okay, now I got to get y by itself. The only way to do that, since it's a log, is to turn it into an exponential. I don't like the look of the x on that side, so I'm going to put it over here so I can make it look like the swoop that we were doing earlier. So I get 4 to the x equals y. It's all by itself. So now I can rewrite it with the inverse notation. Okay? All right. One more, and then you guys are going to try. And I will make a second video on the second part of this. Okay? All right. So we're going to switch our x and our y, natural log, and y minus 3. Now, this is in parentheses, so this stuff is together. Okay? It has to stay together until I turn it into an exponential, okay? I don't like the x on this side, so I'm going to put it over here. I'm going to rewrite this as log base e, so I can see what I'm actually turning into the exponential. So I have e to the x equals, and then I have the y minus 3. I don't need the parentheses any longer because it's not part of that function. Now I can add 3 to both sides. So I get y raised to the negative 1 equals e to the x plus 3. The 3 is big. It is not part of the exponent. Okay? That only happens if it's over here and it gets raised to the power. So now you guys try, and you can click on the next video to get these answers.